Hello everyone, I am the student of Sri Venkateswara College of Engineering, Bangalore from the Department of Electronic and Communication Engineering. This is my another video of the subject Basic Electronics. In this video, the topic is about operational amplifier. Let me introduce myself. I am Nishchita SN, second sem BE. Contents are Introduction to Operational Amplifier, Op-amp symbol and pin configuration, Characteristics of an ideal op-amp, Inverting and non-inverting amplifier configuration, op-amp as a comparator, integrator, differentiator, active filter, voltage follower, op-amp limitations and applications, conclusion. First, we know about operational amplifiers. Operational amplifier are also known as op-amp, is a versatile electronic component widely used in various applications. It is a high-gain differential amplifier with a very high input impedance and a low output impedance. Op-amps are commonly used in amplifiers, filters, oscillators, comparators, and other signal processing circuits. Next, we know about op-amp symbol and pin configuration. The basic op-amp symbol consists of two input terminals, that is inverting and non-inverting, an output terminal and power supply terminals. The inverting input terminal is designated with a negative sign, while the non-inverting input terminal is designated with a positive sign. The power supply terminals are typically labeled as V plus and V minus. Next is characteristics of ideal op-amp. An ideal op-amp has infinite open loop gain, infinite input impedance, zero output impedance, and infinite bandwidth. It exhibits perfect linearity, meaning the output voltage is directly proportional to the difference between the input voltages. Ideal op-amps have zero input offset voltage and zero input bias current. Next one is non-inverting amplifier configuration. The non-inverting amplifier configuration is one of the most common applications of an op-amps. It provides voltage amplification while maintaining the same polarity of this input signal. The gain of the non-inverting amplifier is determined by the ratio of the feedback resistor to the input resistor. Next one is inverting amplifier configuration. The inverting amplifier configuration is another commonly used application of op-amps. It provides voltage amplification with inverted polarity compared to the input signal. The gain of the inverting amplifier is determined by the ratio of the feedback resistor to the input resistor. Op-amp as a comparator. An op-amp can be used as a comparator by providing a reference voltage to the one input and the input signal to the other. When the input voltage exceeds the reference voltage, the output switches to its positive saturation voltage. Otherwise, it switches to its negative saturation voltage. Comparators are widely used in applications such as threshold detection, level shifting, and waveform shaping. Next one is op-amp as an integrator. By using feedback components, an op-amp can be configured as an integrator. An integrator performs mathematical integration on the input signal, resulting in an output signal proportional to the integral of the input. Integrators are commonly used in applications such as analogy, computing, filtering, and waveform generation. Next one is op-amp as a differentiator. An op-amp can also be configured as a differentiator by using appropriate feedback components. A differentiator performs mathematical differentiation on the input signal, resulting in an output signal proportional to the derivative of the input. Differentiators are used in applications such as signal analysis, waveform shaping, and frequency response testing. Op-amp as an active filter. Op-amps are widely used in active filter circuits to achieve precise control over the frequency response. Active filters offers advantages over passive filters such as adjustable gain, high input impedance and low output impedance. Active filters are commonly used in audio systems, communication system and instrumentation. Last one is op-amp as a voltage follower. A voltage follower, also known as buffer amplifier, is an op-amp circuit that provides unity gain and high input impedance. It acts as a voltage amplifier with a voltage gain of 1, allowing it to replicate the input voltage at the output. Voltage followers are used to isolate circuit stages, provide impedance matching, and prevent loading effects. Op-amp limitation and considerations. Op-amps have limitations such as infinite open loop gain, non-zero input offset voltage, and limited bandwidth. Careful consideration must be given to the power supply voltages, common mode rejection ratio, and maximum output current. Proper decoupling and grounding techniques should be employed to minimize noise and ensure stable operation. Op-amp packages and variants. Op-amps are available in various package types, including dual inline package that is DIP, surface mount technology that is SMT, and small outline integrated circuit that is SOIC. Some op-amps are available in single, dual, or quad configurations in a single package. Specialty op-amps with specific features such as low offset voltage or rail-to-rail operation are also available. Op-amp selection guidelines. When selecting a op-amp, consider factors such as required gain, bandwidth, input or output voltage range, and power supply voltage. Consider the input and output impedance requirements as well as the required temperature range and noise performance. It is important to consult the op-amp datasheet for detailed specification and perform characteristics. Next, we know about op-amp applications. In that, first one is in audio systems. Op-amps play a crucial role in audio systems from preamplifiers and equalizer to audio mixers and power amplifiers. They are used for signal conditioning, filtering, amplification, and impedance matching in audio circuits. Op-amps with low distortion and high slew rate are preferred for high fidelity audio applications. Op-amp application in instrumentation. Op-amps are extensively used in instrumentation circuits such as data acquisition systems, sensors, and transducers. They provide signal amplification, filtering, and conditioning for accurate measurement and control. Op-amps with low noise, high precision, and high common mode rejection ratio and desirable for instrumentation applications. Next one is op-amp application in power electronics. Op-amps are employed in power electronics applications such as switching regulators, motor control, and power supplies. They are used for voltage and current sensing, feedback control, and protection circuits. Op-amps with high output current capability and wide bandwidth are preferred for power electronics applications. Next one is op-amp application in communication systems. Op-amps are utilized in communication systems for signal conditioning, filtering, and modulation or demodulation. They are used in audio amplifier, mixers, modulators, and demodulators. Op-amps with high slew rate, high gain bandwidth product, and low distortion are preferred for communication systems. Op-amp application in control systems. Op-amps are widely used in control system for feedback control, servo system, and motor control. They provide amplification, filtering, and signal conditioning for precise control and regulation. Op-amps with high gain, low offset voltage, and high slew rate are desirable for control system applications. Op-amp troubleshooting and debugging tips. When troubleshooting op-amp circuits, check for proper power supply voltages and connections. Verify the integrity of input and output signals and check for incorrect resistor or capacitor values. Oscilloscopes and multimeters can be used to measure voltages, currents, and waveforms for debugging purposes. The last one is summary and key takeaways. Operational amplifiers or op-amps are versatile electronic components with high gain and high input impedance. They are widely used in various applications, including amplifiers, filters, oscillators, comparators, and more. Understanding the basic configurations, characteristics, and applications of op-amps can help in designing and troubleshooting electronic circuits. Thank you for watching my video. Like my video.